Okay, so I'm going to talk a little bit about homemade science and skepticism and how you can do these little science experiments or skeptical experiments with your kids, in your classroom, at home, for friends, whatever. And I'm interested in this for a couple of ways. I'm in the middle of a program right now that's called Tomorrow's Professor Today, and we're learning a lot about teaching styles, learning styles, and pedagogy, so how you approach things that you teach in your classroom. And so I'm really interested in these learning-centered pedagogies, not just some instructor at the front lecturing at you for an hour, but how to actually get hands-on experience, engaged learning. For example, the little guy with the nuts, if all you're doing is sitting around reading about how stuff works, you're not really learning as much. And science, a lot of science is hands-on, especially when you're demonstrating basic science concepts. So this is a really messy hands-on, or a little bit messy hands-on experiment that we did in our astronomy outreach program. I'll tell you in a little bit. And kids like to get dirty and like to, touch things and do experiments. And so that's really helpful, teaching science to kids. And also the emphasize the skeptical nature of doing your own tests, doing your own work, doing your own research. And I just finally, the other night, finished reading Benjamin Radford's book. I mean, that's what we're here as skeptics, is questioning things and doing the research yourself. So a couple of ways which you can do home science. There are a couple of resources. You can go online and just kind of Google home science experiments. There are books of all sorts. One good resource, does anyone here listen to podcast Beyond Belief? It's a parenting podcast. They're actually changing their name to Parenting Within Reason. And there's a segment that Lori Tarr does called Project Science, and she explains various science projects you can do with your kids. One of them is making slime. Another one was a teabag rocket that they did at Dragon Con. So I would definitely check out that podcast as one kind of place where you can do home science with your kids. It's also good from a standpoint of consumer advocacy. There are some claims and tests that you can do right at home with your kids, show them that, well, don't always believe everything that you see. And this is actually a screenshot from a YouTube video. As we were talking about YouTube before, there's all kinds of junk on YouTube. And one thing, a friend of mine sent me this link to this Life Ionizer, this bottled water test, saying, oh my God, I'm never going to drink bottled water again. Look at this, look at this. And the claims were, so they made some medical claims about ionized water and how that balances your body pH. And so one thing, and then they tested all these bottled waters with a little dropper pH tester and found that all of these bottled waters are really pretty acidic. So this is an example of they turn the labels around, but you can tell what label it is. It's Dasani. Brain recognition with the color. And he does this little test and shows, oh, this is really acidic water. This is bad for you. And so when you get this kind of thing from your friend, for us, okay, let me craft a reply now. And I, included a link to some, debunking some of the medical claims, saying, your body pH doesn't change that much. You can't change it with water. But that wasn't enough for me. I was kind of disturbed by this claim that bottled water is so acidic and can be bad for you. So I ended up crafting a response of my own, a response video, which I could demonstrate a little bit here. And this is something really easy you can do. Thank you, Tanya, for your coffee cup that I could use. So I just cracked open a bottle of water, same bottle of water that they have in the video, and went to a science supply store online and got one of these little pH droppers. So sort of just like what he's got there up there. And so here's the Dasani water, same thing he's using in the video, and you drop a few drops in. I don't know if you guys can all see it. Comes out yellow. Yellow's about a 6 on the pH scale, so really close to neutral. And so I did this video where I tested all these bottles of water with this pH tester and showed, and sent it back to my friend and said, oh, by the way, I'm getting a completely different result. And she was like, oh my God, that's so cool. And she forwarded it back up the email chain. So that was one little simple experiment that you can, type of experiment you can do. To do this experiment with your kids, do this experiment for your friends to show them, well, don't always believe what you see on YouTube, don't always believe what you see on TV, and it was a fairly inexpensive project. those of you who know me know I've talked a lot about this program called Dark Skies, Bright Kids. So I am not a parent. I do not have kids. So the idea of me talking about home science you can do with your kids is a little weird, but I do have some experience doing this in schools. So we have an after-school astronomy club in Virginia called Dark Skies, Bright Kids, and we do lots of social hands-on activities with third through fifth graders in public schools in our county. And you might be thinking, well, astronomy's not hands-on. You can't, go out to the universe and reach stuff. But there are a lot of scientific concepts and astronomy concepts that you can bring in as a hands-on experiment. And we're trying to show them that science is fun and creative and exciting, get them to ask questions. We give out little stickers for when they ask a really good, deep question, and they can trade in these stickers for astronomy swag at the end, and develop problem-solving skills. And so in addition to the hands-on nature, we also meet with them once a week, the same group of kids, and so we actually form bonds with them and do all this stuff. So, so for example, we get to make comets. This is one of my favorite ones. I want to do this here, but I didn't want to keep track of dry ice all day. You get mud or charcoal dust, water and dry ice, and you pack it together. You use, heavy gloves so you don't burn yourself on the dry ice, and you make a physical analog of a comet that a kid can hold and run around with and actually see the gas coming off, and you explain that's like the gas in the tail of the comet. And so they can physically hold something and see what it's made of. Bringing that down to Earth. Of course, we do rocket launches, which is everyone's favorite thing. And then, true to our name, Dark Skies, Bright Kids, you take a telescope out under some of the darkest skies on the East Coast and show them what's out there. So I'd like to demonstrate another simple science experiment you can do at home. We've got a bunch of them as lesson plans up on our website. But can I get a few volunteers? Yes. Anyone else? Yeah. And one more volunteer. Who's coming? Oh, shiny. Okay, so I wanted to get across the idea of invisible light, so types of light we can't see. I'm a radio astronomer, so I love that stuff. And I found these ultraviolet sensitive beads. Since we're not outside, I did borrow an ultraviolet light from one of our labs, and so luckily we had a sunny day when we actually did this experiment with the kids. And you hold these beads, out under visible light. They're white colored, and then you hold them out in the sun or under this invisible, They're all different colors, yeah. So they're starting to get dark now. And so we had a little craft time. The kids made jewelry out of these. But I also wanted to show a type of scientific experiment. So, ta-da! Colored beads. So, and so they made jewelry out of them so they could take them anywhere they wanted. Okay, so each of my 3 volunteers gets a little bag of beads. You see where this is going? Okay, and I've got 3 bottles of sunscreen. And notice I've covered up the SPF factor. And so this is getting across the idea of what a blinded test is for 3rd graders. It's not double-blinded because I know, or at least at one point I knew what was on these labels before I gave it to them. So I randomly assigned letters, and so each of you gets to pick one.
This one. And squirt a bit in there and then massage it.
Yeah, you can put it on top of the bag. You can just kind of slather it on top of the bag.
Which would you prefer?
It's up to you. I've never done it on the inside, but if you wanted to keep the beads nice and hang on to them, you might put it on the bag. Okay. Yeah. Because then you can keep the beads. And so this is, again, messy hands-on science with kids as you give them a bottle of sunscreen, and it was everywhere. So this is an outdoor activity. Like that. So you could slather it on. And we left him out in the sun, and our sun is going to be this UV lamp here. So these beads, if you just Google, ultraviolet sensitive beads, you get all different websites that'll show them. Okay, so you want to... Yep. We'll put them all under at the same time. Some sense of scientific controls. All right, so... That's right. I didn't have them all with me, but when we did this experiment, we had 6 different bottles, and one of them was like hand lotion. So, are they all getting evenly illuminated?
No, not this one.
I think I might have used less suntan lotion than.
Yeah, there's definitely different amounts.
I think the parameters of this.
Yeah.
I burn easily, so I use a lot.
I'm thinking next time we all need to use like a teaspoon or something like that.
Measure it out. Yeah,
Measure it out, and then science.
Science. All right, so you want to turn them over to the clear and see if you can see who has the lightest and who has the darkest.
I think I have the lightest.
You have the lightest.
I have the darkest.
You have the darkest. How does yours compare to his?
Mine look like this.
Oh yeah, mine
And
are right in
hers
between.
are more pastel.
As he gets, Steve.
All right, so which one changed color the most?
Mine did.
Which one
was
did you
the
have?
Hawaiian one.
The Hawaiian? Right, so now you can do the reveal. You have them guess. You have them, set up the bottles in the
I'm
area.
guessing 15.
You're guessing 15?
Four.
4.
Wow.
So yeah, when we did this with an actual control, there was no difference from the control. So who was the next darkest?
Me.
You? Which one did you have?
I had A.
You had A.
So now I'm guessing 15.
I think you're guessing 15. It's actually 30.
Oh,
I
okay.
think the 15 was probably my bottle that I ended up back in my bag where it belonged. And then yours was the lightest.
Although I used a lot.
SPF 85.
Oh,
So,
it works.
all right.
We should
now have-
graph this.
So that's, another, so
Now, what do you want us to do with the messy bags?
I'll take those. I'll take care of them. Messy.
Would you
Okay.
like me to get you some napkins?
Oh,
you've
yeah,
got
get a chance. Oh, no, I don't. I'm just going to put them in the bag. All right, so that's... So you can see it's a really cheap, easy way to show students, scientific method, blinding an experiment with, typical household items. We have one outstanding question. So I'd like to open up for discussion now. If you have your own examples of cool science stuff or skeptical projects you can do with kids at home. And also, our group is now that we've done the pilot group and then we've done the second pilot group, we're now starting to look more closely at assessment. And how do you do assessment in a situation like that? How do you assess the students' learning without giving them a test? Because one of the things that we're kind of opposed to is sitting down and acting like it's a classroom.